Today we are going to discuss alkynes. Alkynes belong to unsaturated aliphatic hydrocarbons. They contain carbon-carbon triple bond in their structure. The general formula of alkyne is CnH2n minus 2. They contain 2 hydrogen less than alkenes and 4 hydrogen less than alkanes. Contain 4 hydrogen less than alkanes and corresponding alkanes you can write. And 2 hydrogen less than corresponding alkenes. So alkynes are unsaturated. That means they have triple bond in their structure. Their general formula is CnH2n minus 2. They contains 4 hydrogen less than corresponding alkanes and 2 hydrogen less than corresponding alkanes. This triple bond linkage is also called acetylenic linkage, because the first member C triple bond CH, this HC triple bond, this is C2H2, it is also called acetylene. Common name is acetylene, Eupac name is ethyne. So in alkynes, the suffix used is -ine. This series is also called acetylene series. Series is also called acetylene series because the first member is acetylene. So the alkyne series is also called acetylene series because the first member is acetylene.
Okay.
They are more reactive than alkenes due to triple bond, due to presence of triple bond, due to presence of carbon-carbon triple bond. Sources of alkynes. They are less encountered frequently as compared to alkenes. Less frequently encountered as compared to alkenes. Main sources for them being natural gas. Main sources, natural gas. Natural gas and higher alkanes. Higher alkanes obtained from petroleum. Any problem up till now?
No, sir, it's fine.
Now we will discuss the nomenclature. So the common system first member acetylene is the name C2H2. So first member is acetylene. Nowadays this system is no more used. It is obsolete now. Okay.
Okay. Done, sir.
So we will focus more on common name, IUPAC name. So first member is having 2 carbons, so it is ethyne. Second member is having 3 carbon, so it is called propyne. There is another system of naming that is called derived name. So like for ethyne we write acetylene, for propyne we write methyl acetylene. Okay, understood?
Okay, sir. Yes.
We will focus more on UPEC system, IUPAC system.
Okay.
Can you tell me the name of this compound?
Butane.
Yeah. So you can say but1-ine also, because there is a possibility of but2-ine also. Okay, so it is but2-ine. So the position which gives lowest number to triple bond has to be written. So it is 1, 2, 3, 4. It must be written 1, 2, 3, 4. You can write this with either name. Okay, so this is but1-ine and this is but2-ine. Understood?
Yes, sir.
These two are position isomers. What is the name of this compound?
N2N9.
Right. What is the name of this compound?
Sir, Pen2N.
Before we used to write 1 pentyne also, okay? And 2 pentyne. Okay?
Okay. Okay,
Now
sir.
we focus on writing like pen2-ine, pen1-ine. Not that. Now the structural formula.
Sir, for which one structural formula?
This is the Lewis dot symbol where X is the electrons of carbon and dot is the electrons of hydrogen. So this is the electronic structure. The structural formula is C triple bond C. This is the structural formula. This is the electronic structure. Structural formula can also be written like this. Okay?
Okay.
So it has the presence of triple bond. Presence of triple bond.
Done, sir.
Now we are going to discuss methods of preparation. Okay?
Okay, sir.
of preparation. So lab method first. Preparation. So we take calcium carbide. Treated with water. So it becomes acetylene plus calcium hydroxide. Now from where we get calcium carbide? So calcium carbonate is heated, we get calcium oxide plus carbon dioxide. Calcium oxide is treated with coke, it forms calcium carbide plus carbon monoxide. Okay. So calcium carbide when treated with water gives acetylene, also called ethyne, plus calcium hydroxide. Okay.
Okay, sir.
So we take a conical flask which contains calcium carbide to which cold water is added drop wise. Okay.
Okay.
Now it also contains some impurities. So impurities are hydrogen sulfide, phosphine, ammonia, even arsine. Hydrogen sulfide, phosphine, ammonia, arsine, ASH3. These impurities are also formed. So when you pass acidly through water, what happens? These impurities are absorbed. Absorbed. But what is left is phosphine. Phosphine is absorbed by acidified potassium dichromate. Okay. And
Okay.
acetic gas is collected by downward displacement of water. Okay, these are the impurities. So they will ask you question, what are the impurities present during the preparation of acetylene from calcium carbide? So hydrogen sulfide, phosphine, ammonia, arsine.
Okay.
Now we'll discuss next method. Next method is from 1,2-dibromo ethane. So we take 1,2-dibromethane, CH2Br, CH2Br, and treat it with alcoholic KOH and heat it or boil it. This will cause elimination. So 1 K plus will take bromine and OH will take what? Hydrogen from beta carbon. Like that, 2 moles of KOH will take away 2Br and 2H plus. So ultimately it will convert to acetylene plus 2 KBr plus water. Okay. No problem.
No, sir.
Ethane will be formed. So it is also prepared from 1,2-dibromo ethane. Third method is from methane. So you take methane, heat it at a very high temperature of 1500 degree. In presence of lactic arc, it will give acetylene plus hydrogen gas. So methane on thermal decomposition will give you ethyne. Okay.
Okay, sir.
So these are the methods, some of the methods by which acetylene or ethyne can be prepared.
And
One more method is there from chloroform. From chloroform. So if you have chloroform, this is chloroform. This is chloroform. Trichloromethane is also called chloroform. So this is chloroform. What happens? The silver powder takes away all the chlorine and it forms acetylene. Understood? It's,
yes, sir.
so silver takes away this chlorine, this chlorine, this chlorine, this. So all goes together and it forms 6 moles of silver chloride and acetylene ethane is also produced.
Okay.
If you want to remember it, you can write like this: CaCl3, 6Ag, Cl3CH, heated. So this takes away all the chlorine, so it becomes acetylene and 6AgCl. Understood?
Yes, sir.
Some physical properties. Ethane. Acetylene is a gas at ordinary temperature. It is slightly lighter than air. The molecular mass is how much? 26 mu, isn't it? Air molecular mass, do you know? 28.8. So it is lighter than air. Okay.
Okay, sir.
It is colorless gas and it has a faint garlic odor. And these are attributed to the impurities present. It is very slightly soluble in water. But it is soluble in organic solvent. Soluble in organic solvents like acetone, etc. Acetone is a very good solvent. Its melting point is minus 82 degrees Celsius and its boiling point is minus 75 degrees Celsius. So these are the properties of, so it is a gas at ordinary temperature. It is slightly lighter than air. It's colorless gas, has garlic odor, slightly soluble in water, but soluble in organic solvent, melting point and boiling.
Okay.
So here the vapor density is 13. Here the vapor density is 14.4. Okay.
Okay.
Keep in mind that molecular weight is equal to 2 into vapor density. Now we will discuss chemical properties of ethyne. Done?
Done, sir. Clear.
Chemical properties of ethyne. So first is we will discuss addition reaction. This first category is catalytic hydrogenation. Hydrogenation means addition of hydrogen. Catalytic means in presence of catalyst. So we take acetylene treated with hydrogen in presence of nickel at 300 degrees Celsius. We will get ethene. Ethene will further react with hydrogen in presence of nickel at 300 degrees Celsius. Will give ethane. So this is an addition reaction. You can use in catalytic hydrogenation nickel, palladium, platinum are used as catalysts. Can be used as catalysts. Okay.
Okay, sir.
With nickel, you need to heat, and with palladium and platinum, the reaction occurs at room temperature. So here is the conversion from alkyne to alkene, ultimately to alkane. Okay.
Okay, sir.
Next reaction is halogenation, addition of halogen. We treat ethyne with chlorine in presence of CCl4 solvent. We get 1,2-dichloroethene. 1,2-dichloroethene, also called acetylene dichloride. Acetylene dichloride. This acetylene dichloride further reacts with chlorine, form 1122 tetrachloroethane, also called acetylene tetrachloride. Acetylene tetrachloride. Okay.
Okay.
You can also treat ethyne with bromine in presence of CCl4. Similar reaction will happen. It will form 1,2-dibromoethene, which further reacts with bromine in CCl4 to form 1122 tetrabromoethane. The brown color of bromine is discharged in this reaction, and this is also regarded as the test of unsaturation. Okay.
Okay.
This reaction is only given by compound which are unsaturated. So the bromine brown color, reddish brown color, is discharged in this reaction. So it becomes colorless. The product becomes colorless. But the reaction of acetylene or ethyne with iodine is little difficult. It forms acetylene diiodide as the only end product. Further reaction don't happen.
Okay.
Any doubt up till now?
No, sir, it's fine.
Now we will discuss the addition with halogen acids. So halogen acids. Halogen acids are HX, HCl, HBr, HI, etc. So we will take acetylene and treat it with HBr. One double bond will break and H and Br will be added. So it forms bromoethene. It will further react. Here is double bond. Bromoethene will further react with HBr to form 1,2-dibromo, 1,1-dibromo, 1,1-dibromo, ethane. So final product is 1,1-dibromoethane. First product is bromoethane. Similar reaction happens with HCl. Similar reaction happens with HCl. Written.
Yes, sir.
Next is reaction with ozone. So acetylene or ethane reacts with ozone to form acetylene ozonide. Acetylene ozonide. This is acetylene ozonide. This acetylene ozonide can be decomposed in presence of zinc water to form glyoxal. So it will break from here. So it will form CHO, CHO. CHO, CHO is also called glyoxal. This is ethane, reacts with ozone. So it forms acetylene ozonide, which is decomposed in presence of zinc and water to form glyoxal.
Done, sir.
Next is oxidation. So acetylene undergo oxidation in presence of with dilute alkaline KMnO4. Percent oxygen coming from. So acetylene will form oxalic acid. Oxalic acid is also called ethane dioic acid. Ethane dioic acid. It is a dicarboxylic acid. The oxidation of acetylene in presence of dilute alkaline KMnO4 gives ethane dioic acid, also called oxalic acid. These oxalic acids are also present in tomatoes. Here the purple color of KMnO4 is discharged. So this is actually chemical test, okay?
Okay.
Purple color of KMnO4 is discharged or turns green. This serves as a test of unsaturation. This is also a test of unsaturation. Okay.
Okay, sir.
Now combustion. Just like any other organic compound, acetylene also burns in presence of oxygen to form 4 moles of carbon dioxide and 2 moles of water along with heat and light. So it burns with sooty flame. Burns with sooty flame. In excess air, it burns with a white flame. White flame, evolving heat. Okay.
Okay.
So this was regarding combustion. So combustion of acetylene gives carbon dioxide, water, heat and light. It burns with a sooty flame, and in excess air, it burns with a brilliant white flame evolving heat. Now its reaction with ammoniacal cuprous chloride. So ethyne reacts with cuprous chloride, ammoniacal cuprous chloride, to form copper acetylide. So it forms a red precipitate of copper acetylide plus ammonium chloride plus water. So this reaction is also a test of colored precipitate indicates. So addition product is formed, that is copper acetylide, LIDE, acetylide, copper acetylide. Similar reaction is with ammoniacal silver nitrate. Reaction with ammoniacal silver nitrate. It will form a white precipitate of silver acetylide. Ammonium nitrate plus water. This reaction will form silver acetylide. This is the test for ethyne. These two reaction is the test for ethyne. Okay. So the colored precipitate confirms ethyne. So with ethyne reacts with ammoniacal cuprous chloride, form copper acetylide, red precipitate, whereas with ammoniacal silver nitrate, it forms silver acetylide, white precipitate, white PPT. Very, very important. Now uses of ethyne. It is used in the production of oxyacetylene torch. It is used in the production of oxyacetylene torch for welding metals. Oxyacetylene torch for welding purposes. For welding purposes. And it is used for ripening of fruits. Artificial ripening of fruits. It is used in the manufacture of different organic compounds. like acetic acid, acetaldehyde, acetylene dichloride, oxalic acid, and different manufacturers of polymers, manufacture of synthetic products or polymers, like polyvinyl acetate.